All right. Hello, everyone, and welcome to today's webinar. My name is Jason Lichtman, and I am your host for today. Today's topic, meshing around, how the new Fusion 360 Parametric Mesh Workspace sets the bar for mesh editing and reverse engineering. We have a packed agenda, but I just want to make sure to be clear. Today's webinar is going to be showing you what Fusion 360 could do, as opposed to how to actually do it. If you're looking for more of a tutorial on the Mesh Workspace, we have that available as well. Here's a link at the very bottom here to our YouTube channel. I created a video just about a month ago, maybe 3 weeks ago, where I go over the same tools you're going to see today, but in a different method, a little bit more tutorial wise, as opposed to what it could do as a summary. It's a great video to watch after today's webinar if you're new to this topic, but if you are not new to the topic and you are looking for more of a tutorial, that is where you should go. I will also paste that link to the chat window. So just a moment here while I paste that for all of you, so you could go and review that or bookmark that for later. And so today, what are we actually going to cover? Well, we're going to talk a little bit about me just for a moment, because I'm going to talk a lot today, and it only makes sense for us to get to know each other a little bit. I'm going to tell you a little bit about Autodesk. Who is Autodesk, or what is Autodesk, and what is Fusion 360 in particular? That'll be especially relevant to any of you that come from other software, whether it's SolidWorks, CATIA, NX, Rhino, and a whole host of other competitor softwares. You might want to know a little bit about what Fusion 360 can do outside of the Mesh Workspace and tools I'll be covering. And then we're going to talk a little bit about meshes at the basic level. If you've worked with meshes before and you find yourself getting frustrated on a regular basis, this will explain why that is. So what is the difference between a mesh body and a B-wrap, or boundary representational solid? And I'll tell you a little bit about why they're difficult to work with, or at least why they are more difficult to work with than just solids and surfaces. Then we're going to get into the really good stuff, what you came here to see today, and that's going to be all of the different tools that are in the Mesh Workspace. Now, there are actually a lot of tools, so I'm going to be covering the highlights today of what I think you will want to know about. And then again, if you want to learn how to actually use those tools, that tutorial on YouTube is going to be a great fit for you. So a little bit about me to start. This is me on a particularly good hair day, so to speak. My name is Jason Lichtman, and I'm a senior technical specialist for design and manufacturing here at Autodesk. I focus specifically on Fusion 360, and I come from a background in mechanical engineering. I spent over 10 years in industry, and the 4 years since, all in product design and manufacturing, taking ideas and turning them into 3D models, turning those 3D models into prototypes, and those prototypes into mass production. I worked at a variety of different companies, both OEMs as well as independently as a design consultant. And some of my specialties include design for molded parts, such as injection molded or foam molding, and also, of course, composite molding. I also have a specialty in 3D printing, 3D scanning, and reverse engineering. So today, I think I'm a great pick to be your host for today's topic on mesh editing and reverse engineering. So let's tell you a little bit about Autodesk itself. I'm going to change my settings here, and let's see, to make it so the video comes in a little bit more clear. So I'll tell you a little bit about Autodesk itself. So Autodesk has been around for quite a long time. Started in the 80s with AutoCAD, and most people think of us as the AutoCAD company, but we're a whole lot more than that. We do span across 3 different sectors. So design and manufacturing is what we're covering today and what you see on the screen in front of you. But we also cover M&E, or media and entertainment. Think of animation software such as Maya, 3ds Max, and a whole lot more. That's going to be software to create animated movies like Toy Story, for example, that I watched when I was younger. Or create the graphical effects in some of the more modern movies like Wonder Woman. Let's say that right, Wonder Woman. But we also span across AEC, or architecture, engineering, and construction. So think of AutoCAD for 3D building design, or even for landscape design, Revit for 3D building design, Civil 3D for a whole bunch of different civil engineering projects, and a whole lot more. On the design and manufacturing side of things, we cover everything from design to manufacture and everything in between. So if it means surface modeling of vehicles like the ones you see on the screen in Alias, or if it means engineering more industrial parts, whether it's welded tubes or milling, we cover all of it. And Fusion 360 is what brings it all together. So Fusion 360 is a platform. And as a platform, and hold on just a moment while I make that not blurry anymore. Here we go. Fusion 360 as a platform is meant to cover the design itself, whether you want to design as solid modeling, surface modeling, subdivisional modeling, mesh editing, and a whole lot more, all the way to analyzing your part, or CAE, computer-aided engineering, as we like to call it, to make sure that your part is going to be strong enough, to make sure that your part is going to withstand the vibration or withstand the other loads that it might face, all the way to actually manufacturing, whether you're simplistic and using a 2D laser, water jet, or plasma cutter, whether you're using a lathe and you're doing some basic turning, whether you're using a fancy lathe and you have live tooling, or you're milling 2.5 axis, 3 axis, simultaneous 4 axis, simultaneous 5 axis, we run through it all. And Autodesk is really good at not only creating its own great technologies, but also incorporating other technologies through acquisitions. So on the CAM side of things, you might have heard of a company that had HSM, or high-speed machining. That's integrated directly into Fusion 360 today. Or an acquisition of Delcam for software like PowerMill and FeatureCam and Power Inspect and a whole lot more, also starting to make their way into Fusion 360. Fusion 360 can design not only mechanical parts, but also electronics. There was an acquisition of Camsoft for Camsoft Eagle, and Eagle not only comes as an entitlement with your Fusion 360 subscription, but it actually is also built directly into Fusion 360 itself. So you could design a mechanical enclosure and the electronics that are going to go in it all at the same time seamlessly. That's what Fusion 360 is all about. So if you haven't heard it, Fusion 360 can do any number of different things, but it not only does each of these things, it does all of them. So it's not any one of them, it's all of it in a platform. And that's what Fusion 360 is really trying to accomplish. Whether you're an industrial designer, mechanical engineer, electronics engineer, machinist, or in production, you can use and enjoy and benefit from Fusion 360. So with that, let's jump into the really fun stuff in the deeper dive into meshes. Again, we're going to start with the basics of mesh bodies and what the differences are between those mesh bodies and what you're used to as solids or surfaces, why they're frustrating, and a whole lot more. And then we're going to go into the features themselves. I'm going to do a quick little check at our Q&A, and I don't see any questions or anything in the chat. If you do have any, please feel free to add them. I am happy to take a look at them and answer your questions. We want to make sure you get the most out of this today. So let's go and talk about meshes. What is a mesh body or a mesh file? And I apologize if you already know this, but I do think this foundation is important. A mesh file is a 3D object, but it's represented as polygons. On the left, you'll see what's considered a traditional mesh made of triangles. And on the right is what we call a quad mesh made of quads or 4-sided polygons. Either way, they're both mesh files, and they represent that 3D object. There are a lot of different formats that are available, but the most common are going to be STL. You're going to see OBJ, 3MF, which is actually a new file type for Fusion 360 as of last month. And you'll also see FBX, less common, but still available. So to understand these a little bit better, I think it's important to understand not just what is causing the frustration, but how to alleviate it. Because we don't want you to be frustrated like this guy. We don't want you to be frustrated like these two people. We want you to be much happier and much more successful. And it all starts with understanding how the mesh bodies are described and how they're actually used. And to understand that a little easier, I like to start in 2D. So there are a lot of different ways to represent a 2D image. On my screen right now, you could see two Autodesk logos. The one on the left and the one on the right look the same on first glance, but the one on the left is a vector, which means it's mathematically based. It's described in computer terms as a mathematical formula. And the one on the right is raster or bitmap based, and it's described with pixels. When you look at them from far away, they look the same. But when you start to look at them up close, you can start to see the differences. The one on the left is a little bit more crisp. But if we start to zoom in further, now you really see the difference. The one on the left is still very crisp. The one on the right is a little bit more blurry, actually a lot more blurry. There are two different softwares that are commonly used to edit those kinds of files. I use Adobe Illustrator for vector files, and I use Adobe Photoshop for raster or bitmap images. There are a lot of other options available as well, but for this analogy, I think this will be perfect. The vectors are going to the vector-based program, Illustrator, treats each of these letters as an independent object. On the right, however, the raster or bitmap in Photoshop is treated as pixels. And again, if you look at them up close, you'll see a very big difference. And what looks crisp from far away, when you start to zoom in, starts to look a little funny. But keep in mind that some of these squares in particular are actually gray instead of black. And again, that's like an illusion so that from far away, it looks a certain way, right? But everything is really based on what's the color and which of these little squares or pixels is which color. You can open up your raster or bitmap image in Illustrator, and you can use it to some degree, but it's a limited use. Alternatively, you can open up a vector file in Photoshop, but again, it's limited use and what you can actually use it for. And that should make sense to you because they're defined in a different way, and Illustrator is meant to be looking at vector files and editing vector files. So the raster or bitmap is kind of the oddball in the software. And vice versa is also true. When you bring in that Photoshop image or raster or bitmap image into Illustrator, it can use it, but it's limited in what it can use because it's like an oddball. It's not really meant to edit that kind of file, right? But you can convert those files too. And many of you have probably seen that when you convert from a vector to a raster, it converts perfectly, really quick, really easy, accurate every time. You're going to be like the person at the bottom of the screen here, and you're going to be happy. But the other way around is not exactly the same. To go from the raster or bitmap into a vector causes frustrations. And the reason is because when it's looking at those pixels and it's looking at the grayscale versus the black ones, it has a hard time interpreting what it's really supposed to be as a vector. So you can convert it, but it sometimes has some flaws in it. And right now on the screen, I can see that the vector on the right, while it looks at first glance to be similar to the A on the left, is actually more rounded. The top corner of the A is very rounded. The bottom has some corners that are sharp. The outer corners are sharp and the inner ones are rounded, whereas the original A is all sharp. So the conversion from the raster bitmap to the vector was not as successful as I might like. So how does that come into play with mesh files, right? Because that's what you came here for today. So I want you to think of 3D objects similarly, right? There are ways you can define what they are, and different programs are meant for different kinds of those objects. So this is showing you right now a bunch of different ways you could represent 3D models. Wireframe for something like AutoCAD is one of them. Point cloud data from a 3D scan, mesh data, which could come from a 3D scan, or it could be output from that BREP surface or BREP solid, and even subdivisional surfaces, which is a way to be able to manipulate shapes by pushing and pulling on vertices. If you've ever heard of the term NURBS modeling, that's a subdivisional surface modeling technique. But engineering software like Fusion 360, like Inventor, like SolidWorks, and like many other engineering tools are primarily meant to work with boundary representational, otherwise called BREP, surfaces or solids. Whether it's a surface or a solid doesn't really matter in this case. They're both defined by the boundaries, hence boundary representational. And this is what you're using when you're creating a sketch and extruding a shape or revolving the shape and adding threads and features and all sorts of other stuff in Fusion 360. And just like how you can bring in a raster or bitmap image into Illustrator, and you can use it, but you're limited, bringing in mesh files into a software that's meant to be for boundary representational solids can be done, but is typically limited. And the same is also going to be true with the other body types, but today, of course, we're focusing on meshes. So here's how this comes into play. The same analogy I used about the raster and bitmap versus the vectors, here we are. I want you to think of the boundary representational surfaces and solids as 3D vectors. And I want you to think of the mesh bodies, whether they have triangle polygons or quad polygons. I want you to think of those as 3D raster or bitmaps. And the key is that the triangles or the quads are essentially the 3D pixels, right? And so what that means for you is that if you want to go from the boundary representational surface or solid to a mesh body, it's quick and easy and successful, just like going from the 2D vector to a 2D raster or bitmap. But the other way around, going from the mesh body to the boundary representational solid or surface, that's where you've grown frustrated. Because just like when I went from that raster image into the vectored image, it ended up like ruining the corner, so to speak. You've probably found that it's done that same thing for you. Or worse yet, you can't in many softwares even do the conversion, so that mesh body ends up being somewhat useless. But thankfully, Autodesk Fusion 360 recognizes that mesh files are important, not just for outputting to a 3D printer, but also to be able to edit and to be able to repair and to be able to make serious changes with. And if you are an experienced design engineer or designer, you've probably seen that it's not all about solid modeling. You can solid model, you can surface model, and you can hybrid model between the two. I think you're going to find that now in Fusion 360, you'll be able to hybrid model between solid modeling, surface modeling, sheet metal modeling, your subdivisional modeling, as well as mesh modeling or mesh editing also. It's pretty cool. You probably didn't expect that. Most other software does not do what you're about to see today. And keep in mind that this is very new, even to us at Autodesk and at Fusion 360. So the updates that are all making this possible came out and went live July 6th of 2021. So if you've watched any videos from Autodesk Fusion 360 or one of our partners or affiliates, keep in mind that if that video is older than July 6, 2021, it is probably obsolete. That video that I referenced earlier in this webinar is up to date. That was published about a week after the updates. And so that's a great tutorial for you to watch. All right, so let's go back to our agenda here. This is the part you've been waiting for. Now let's talk about what you can do in Fusion 360 with respect to meshes. We're going to start with repairing those meshes. Then I'm going to cover editing it, both parametrically as well as direct editing, which is not parametric. I'm going to talk about converting mesh bodies to solids without the 50,000 polygon limit that you might have seen in the past. I'm going to talk about converting mesh bodies to editable solids. And this is going to be my favorite part of today's webinar. Just a heads up there. We're going to talk about combining engineered features with mesh bodies seamlessly. And I'll even show you a pretty far out there example to see how far you can go with that. And I'll even show you how to deal with meshes that are impossible to fix, how you can actually wrap a mesh with a surface body seamlessly and easily as well. Now, there's actually more that you could do here than I'm listing. These are just the highlights, so just keep that in mind. So with that, I'm going to jump over to Fusion 360, and we're going to start with what you could actually do. I will take a second to monitor the Q&A real quick, and I'm seeing it looks like that it looks like the link that I gave you for that lesson didn't show up before. Let me copy and paste that again. So just a moment, I apologize. And here's the link to that video. Thank you for letting me know. All right. So someone asked whether or not working with meshes that are triangle based versus quads are easier to work with. Like, is one easier than the other? I'll tell you that in some cases, there are certain features that only work with the triangle-based meshes as opposed to the quads. There are other features, though, that only work with quad meshes that don't work with triangular meshes. Most meshes that you end up downloading, whether it's from Thingiverse or from another colleague of yours, those tend to be triangle-based meshes. So I'm going to focus on those today, but there are workflows that are special for quad meshes as well. All right, so we're actually going to start with this gearbox cover, and it actually has color in it. So I'm going to turn on my face group, or turn off my face group display so you can actually see this with color. And we're going to talk a little bit about the file that came in and how we can work with it. So this mesh came in with color because the file I imported had color. Of the mesh file types you might have seen, STL, OBJ, 3MF, those are the three most popular. 3MF and OBJ can contain color and texture information. STL files will never contain color information. So just keep that in mind as well. So here I have a gearbox cover with color, and it is looking really good. But what if I import it and it has problems? I might want to fix it. After all, if I don't fix it at the beginning, I'm going to be left with or stuck with those problems for however long I'm working with this file. So let's say I start off with a new design and I go to my mesh tab here at the top. And if you've watched any of our old videos before, the mesh tab used to only show up under certain circumstances. It now is here all the time. So you always have it available. You can insert a mesh and choose any file you'd like. I'm going to bring in the gearbox cover that happens to have some issues. It looks colorless, but I could also see right over here, if it shows up for me, that I have some issues with this mesh. If I look under the bodies, I could see that there's a warning, and it tells me that this mesh is not closed, is not oriented, does not have a positive volume. Those are not good things. You want those things to be, you want the mesh to be closed, you want it to be oriented, and you want it to have a volume. We have tools to repair that mesh under repair, sorry for the rhyming, but under repair, you can go and repair that mesh. You could also just click on this yellow warning. The repair tool or technology that comes from it is really coming from Autodesk NetFab, a slicer for 3D printing, and it does a whole lot more. But this technology is making its way into Fusion. So you'll see that we have 4 different repair types that are available. And actually, if you choose the rebuild repair type, you'll have 4 different options within it. So there's a total of 7 different ways you could repair that mesh. You can preview the fix, and you also have the ability to analyze the defects themselves in a little bit more detail. This is what we call a preview feature or a beta test feature. You can turn this on under your preferences and under preview features. But if this isn't showing up on your screen, that's why, and you could just go and turn that on. Keep in mind, though, that when it comes to mesh repair, you're getting lots of different options to be able to fix your mesh so that from now on, you have a fixed mesh and you're not stuck with bad issues that are going to linger. Once you've repaired the mesh, you might want to edit it. And when it comes to editing a mesh, there are a lot of different ways you could do it. You can edit that mesh parametrically. Right now, the timeline of my Fusion 360 is on. So everything that I do is recorded feature by feature, just like standard solid modeling or surface modeling. I also have the ability to directly edit the mesh, either by right-clicking on the original mesh feature and saying edit feature, which will pull me into this direct mesh editing environment, or by going to modify and choosing direct edit. There are some slight nuances between those two options, but the key really is that you get the ability to edit the mesh parametrically or not parametrically. And when you're editing that mesh parametrically, what you're selecting when you choose one of these modify features, you're selecting to edit a body or a face group. So now I have to define what on earth face group is. A face group is a group of faces. In particular, a group of these triangles. And you can manually group them together, or you can generate the face groups by saying prepare, generate face groups, selecting the body itself and letting it go and do its thing and calculate the face groups. It's really good at doing this for you, but there are times where you might want to do it manually as well. And the whole benefit of grouping these faces together is that now you get to select areas of your model based on whether it's really representing a flat surface, or it's really representing an arc or a fillet or a hole or something like that, so that you could work on just that one thing. And it makes it really easy to be able to do that. But what you'll notice is that I'm selecting bodies and I'm selecting face groups. At no point here am I actually selecting individual triangles. For a geometric shape like this, I actually prefer to work with the face groups or the body, but for a super organic shape, I would very likely want to be more at the pixel level, so to speak, or the triangle level. And for that, you're not going to be able to do it in the parametric environment, but you can still make those changes. For that, you're going to want to go into that direct editing mode, whether you go to it through the modified direct edit, or you just go and edit the feature. Either one is perfectly fine. So let's go and show you what that would look like. I'm going to go and modify, direct edit, and I'll go and hit OK. And now I'm in the direct mesh editing environment, and I can actually select individual triangles. I have a selection palette here on the right. I could change the size, and now I'm selecting them in a much bigger group at once. I can also select this back faces, so I could select the faces that are in the back side of the mesh as well. The point simply being that you have the ability to select the individual triangles or go kind of more bigger picture. You will get slightly different tools when you're direct editing, because some of these features are only available at the pixel level or the 3D pixel level versus like the face group or the body level. But just know that you can make a whole lot of different changes here. So let me show you another example that'll be a little bit more interesting than this gearbox cover. So let's go and close this one out here. And I have a dental scan. Believe it or not, this one's actually my dental scan, but this is a great example of a detailed mesh with quite a few polygons. Let's go and take a look at how many. And it looks like I have 226,000 polygons. That's a lot. Again, if I want to edit this at a pixel level, so to speak, I can just go and edit my feature, come in here. I can change my mesh selection palette. Let's make that way smaller even. If I wanted to get rid of just the tip of this particular tooth, and I'm going to flatten this quite a bit for you, I could go to modify, erase and fill, and we're going to go and hit the OK button. And there you have a flattened tooth. You know, probably not a great fit for me in particular, but you get the idea that you can go and make those changes at the pixel level, so to speak. Once I'm done at the direct editing or the pixel level changes, I can also make changes at the bigger picture level too. So let's go and make some of those changes. And actually, I think the way that I just did that isn't what I was hoping for. I'm going to cheat slightly, and I'm going to just reopen this file rather than fix it the longer way for you. All right, so here I am in a file. Actually, we're going to go back in time here just a little bit, and I'm going to go and create a quick sketch from the side. And I might do something as simple as this line. I could also go and create a plane on that particular line. And under my mesh parametric tools, I could go to modify, and I could even make a plane cut and trim off the bottom of this particular dental scan using this plane. I could trim it and keep it open, or I could also close it, which is what I want to do here. And Once I hit OK, it's going to go and update, and that's looking really good. But keep in mind that this is still parametric. So if you want to go and make a change to the sketch, and I want to hug a little bit higher up, closer to the teeth, I go and hit finish sketch. It'll update the plane that was created and therefore update the trim that happens as well. The next thing I might want to do is to hollow this out. And this is particularly useful for complex solid bodies that might not want to shell in the solid modeling environment. I can simply come in here and select my body, choose a wall thickness and hit OK, and it will nearly instantly shell out or hollow out this particular mesh. I see it here in my bodies folder. It is indeed a mesh, but I can't really see the hollow aspect of it. So let's change the opacity control. And now you could see that it's hollow on the inside. Again, if I need to make changes, all I have to do is edit the feature, change the wall thickness to maybe 2 millimeters this time, and it's going to go and update because, again, this is parametric. Now, I've used a lot of different CAD softwares out there, and I'll tell you, most of them do not play well with mesh bodies. Remember, we talked earlier about how those mesh bodies are a different way to define the shape, and they don't necessarily jive with the way the software is intending to make those changes. So it's the oddball within the software. But as you can tell here, Fusion 360 is making mesh bodies a first-class citizen. So you can make changes in a variety of different ways and hybrid between your standard solid modeling and your mesh editing. And this is all parametric, which means that the usefulness of the edit is that much better. You're going to be able to make the changes and then be able to go and change the numbers, because we all know that you're unlikely to get it right the first time. I know I never get it right the first time, and so I love the ability to go and edit those features. So we covered so far editing meshes, at least the basics, in parametric or direct editing. Now let's talk about converting mesh bodies to solids. I'm going to show you a slightly different example for this. So let's close out our dental scan. We're going to get to this car in just a little bit, but let's start with this isobaric subwoofer. Even I don't know what isobaric means, but I'll tell you this is a subwoofer enclosure. And this one was actually downloaded as an STL file from thingiverse.com, right? Thingiverse.com, open source, you could download anything you'd like, whether you're using Fusion 360 as a hobbyist or personal user, or you're a commercial company, whether it's a small business, medium business, or even enterprise business. There are plenty of times where you might want to just download a model from Thingiverse, or maybe somebody sent a file for 3D printing as an STL file, and the original design file is gone. You have no idea where it is, and you need to make changes to it. Well, in Fusion 360, you can import that STL file, and you can convert it into a solid. Here I have in my bodies folder a mesh. If I want to convert this into a solid, all I have to do is go to Mesh, Convert Mesh, choose the faceted option here, choose my mesh, and hit the OK button. But before I do, let me actually just show you something that's going to be important. Under my properties bar here for my mesh, I could see that this particular mesh has 72,160 triangles. And that's important to note because in the past, Fusion 360 could do this conversion, but it was limited to 50,000 triangles. And that could mean frustration. And we're trying to make this a whole lot easier for you. So let's go and convert this mesh. I'm going to go and convert the mesh using the parametric. I could also choose base feature, which is really direct editing. I'm going to choose faceted, and it's going to create a face for every single triangle that was in this model. And by that, I mean, for every facet, those 72,100 and something facets in the model, I'm now going to have a BREP solid with just as many faces. So this flat face on the side that has two triangles will continue to have two triangles. It's going to take about probably 10 more seconds or so. It'll complete, and then we'll go and take a look at this. And I'll show you that you can clean this up pretty easily in Fusion 360 as well. So once it's clean like this, it actually still looks like the mesh did, but the edges are a little bit bolder. I can select a triangle that represents a flat face, and I could hit the delete key on my keyboard and it will find other faces that are also flat within a tolerance and clean it up. So here I have a bottom that is quite ugly looking. I'll go and hit the delete key on one of those triangles. It's going to go and find all of the flat faces and try to clean it up. And that looks way better. If I want to do the same thing on the top, I can, and I'll go and select, let's say, this face right over here. Oh, wrong thing, right there. And I'll go and hit delete, and I'll do that one last time. Remember though, whether I clean this up or not, this is still a solid body, and you can make all sorts of changes to this model. You can create a sketch and extrude new geometry that joins to the existing. You can extrude cut. You can do a whole lot of different things here. But keep in mind that this cleanup does make your life easier, but it's limited to flat faces. The cleanup will not work on the fillets, for example, that are in this corner, right? I can clean that up myself kind of more manually, but if there are a lot of fillets, that would be pretty time consuming. The key though for now is that if you would like to convert to solid and that's all you care about, you can very much do that in Fusion 360, even if your particular mesh is more than 50,000 triangles. Keep in mind though that the more triangles or polygons you have, the harder it is going to be on your system. So unless you have a super awesome workstation, be wary of trying to convert a 2 million polygon mesh, as that would be pretty rough on your computer, right? Can it be done? Absolutely, but it is going to reduce your performance. So let's talk about another way to convert the mesh into something that's more usable and editable. For that, I'm going to go and delete what I've already done here. So let's go and delete that for a second. And we're going to start from scratch on how to do the conversion a different way. Remember earlier, we talked about face groups and how you could generate a face group to be able to group together individual triangles based on what would be representing a flat face or an arc or a fillet or a cylindrical face or a hole, those kinds of things. The generate face groups feature is automatic and fantastic. You can play with those settings to be able to get different results, and you can stack that feature together to be able to go into more detail. So if you do have trouble with the generate face groups feature on a particular model, you can use kind of more coarse of a method and then go into more detail on individual face groups to subdivide it further. Again, I'm not trying to teach you how to do it in this video. The tutorial on YouTube is a great fit for that. Really here, I'm trying to show you what it could do. So if you generate face groups and you turn on the face groups visibility, you're going to see the grouping for this particular file. And for this particular file, it grouped all of the flat faces, all of the arcs. And if you zoom in, and this is what I believe is the isobaric nature of this enclosure, those little triangle pod things on the inside, but it even groups all of those individually as well. And it did a great job, and I didn't do anything special to be able to do that for this. But if I want to truly edit this easily, there's another conversion method that I think is fantastic. And this one is almost magical. So I'm going to zoom out so you can actually see what this is doing. I'm going to choose the prismatic method, the body itself, and I'm going to hit the OK button. And in just about 5 to 10 seconds, it instantly converts that mesh into a solid body. It is a dumb solid body in the sense that there's no history, but this is very much editable. And it is very much a clean body that is easy to work with relative to nearly any other option I could imagine receiving. And it's fantastic that I have something like this, because now I could zoom in on an area. If I want to make this hole bigger, I could go and make this hole bigger. If I want to get rid of the hole, I can select the hole and hit delete. If I want to get rid of the fillet, I can just hit delete. If I want to get this material to be taller, I could simply drag this however tall I would like. And those kinds of changes on a mesh file, man, people just didn't think it was possible. But I have to tell you, the Autodesk Fusion 360 development team blows my mind every time. And the updates from July 6th of 2021, these are my favorite to date. This is going to allow you to take an STL file, whether it's from Thingiverse, from another source, or even internally within your company, and be able to make changes very quickly and very easily. This conversion method does require you to create the face groups first, and does require that face group to actually be generated correctly. So for all the triangles of a fillet to be in the face group, for example. The other thing to note about this conversion that's important is that this particular one is available only for the commercial customer base. And I know that that might disappoint some of you. We love our hobbyists or our personal use users, but we do have to be able to have income to be able to make these features for you. And so this particular feature is only under the commercial version. So please, if you are a hobbyist or a personal user and you are considering upgrading to commercial use for it, please let us know. We are happy to help, and we are happy to be able to help you evaluate if it's going to be worth that upgrade, but this is not going to be in the personal use version, right? There are a lot of other features. Most everything else of Fusion 360 is in the personal use version, but this is one of the few things that is not. I'm going to check real quick about the Q&A section here. Someone asked about the early adopter package. The early adopter package was a purchase. So again, if you purchase Fusion 360, whether you're paying the current price or you're in the original price point, you have access to this feature. And I don't see any other questions besides a request for a link to the tutorial. So let me just go and put that in here one more time. There we are. And then we're going to get to the next section. I do see more questions in the Q&A section. I will answer those shortly. Perfect. All right. So the next thing we're going to do is what happens if you can't or you don't want to convert the mesh, because maybe you just want to add engineering features to it. So now let's start talking about automotive examples, some of my favorites. We're going to start with this 1991 Dodge Ram Club Cab. And I'll admit, I'm not lucky enough to own one of these gorgeous beasts, but this example is about the hood ornament, right? Some of these vehicles, the hood ornament broke off, you need to replace it. Maybe you're going to just 3D print it. But either way, you need to edit a very heavy mesh file. And so let's switch over to a 3D model of this particular vehicle. We're going to go and hide our canvas. Let's make this look a little nicer. So we'll also get rid of our face groups temporarily here. Give that a second. Oh, that looks fantastic. Super happy with that. And what we're going to look at is the hood ornament itself. So let's do a little close-up. This is the area we're looking at. Actually, we'll do more of a close-up. This is the hood ornament in question. And what we're going to do is we're going to take a mesh that already exists, and I'm going to show you how to add engineering features to it while keeping it a mesh. And that's the important part here. So let's hide the vehicle at this point, and let's take a look at the mesh. I already added those engineering features, but here they are. We're going to add this boss sticking out for alignment, and then these screw holes that are threaded to actually attach it to the vehicle. And we're going to start much earlier on here. So let's roll the history back just a little bit. Give that just a moment. There we are. So this is the mesh as I downloaded it. It is very detailed. I think it's actually gorgeous. But if we start to look at the detail on this mesh, like how many facets do we think we have? I know it's a lot, but it turns out it is 582,000. That's enough for me to not really want to convert this into a solid. Could I? Yes. But then I'm going to go and I'm going to add features to it. And in the end, I'm just going to convert it right back to a mesh. I'm going to ultimately 3D print this. So if I have a complicated mesh like this, I might just want to leave it as a mesh. And that is perfectly fine in Fusion 360. Remember, this is still an engineering tool. So you can create a sketch like this one here. And let's actually go and look at this a little bit closer up. There we are. So here I have the bottom or base of this particular mesh. I have my circles representing where I want those features and the exact size of those features. Again, very much engineering controlled and precise. And once I create those, then I could go and turn these into solid features. So for example, I could use the extrude feature to create that boss in the center. Give it a moment for it to show up. There it is. So here is the boss in the center. I'll also go and add a chamfer to it. At the moment, it's a separate body, but it's a solid body. I'll also show that you can create the feature that'll end up being the threaded bosses. Right now, they're just threaded body. Sorry, they're just bodies, cylinders. Now I added the thread to it. And then we could go in and tessellate. And tessellate, in case you need to find it, is under Mesh, Tessellate, and it'll convert a solid body into a mesh. So instead of saving it as a separate file on your computer and then re-importing it, Tessellate will just convert it from the solid into a mesh right away. And if you remember from the PowerPoint part of today's webinar, you can convert from the solid body or BREP body into a mesh instantly and perfectly every time. So not a big deal, right? I'm just going to go and convert that. I'll also go and convert the helical area or the threaded areas. And keep in mind that one of the things I could do with mesh bodies is that I can modify them by combining them. There's a new combine tool in Fusion 360 as well. So what you're going to see now is here's the original mesh, the 500 and something thousand polygon mesh. And I can go and combine the other bodies, which were converted into a mesh, combine them with the rest of my mesh. And the end result is that I have one mesh body with all of my features that I wanted in it. That's absolutely amazing. If you want to take this even further, here's another example. I won't show as much detail on it, but I will show you what you can do. So same idea, I have a vehicle and I want to create this hood ornament, which is called a leaping Jaguar. And this is from a 1963 Jaguar S-Type. And this particular file came in as a mesh body, no surprise. Enough detail in here that I don't actually want to convert it into a solid. But what I do want to do is I want to create the base for this, but the base is actually quite organic. In fact, if I show you here, this is the shape of the hood ornament. Here you could see the base and it's very curvy, so to speak. Here's another view of the same thing. So how do we create it? Well, remember that just like you can hybrid model between solid modeling and surface modeling, you can also hybrid model now with mesh modeling and with sub-D modeling, or T-splines, as we like to call it. So here I have in black, let's go and show that in more detail, a subdivisional surface body. And I can push and pull on any of these faces that I would like. I can create whatever the shape is that I want. And once I'm happy with it and I hit finish form, it's actually going to convert it into a surface. Let's actually hide the vehicle. Now you could see that surface. I also can go and patch the very bottom of that surface and stitch it together, turning these two surface bodies into a solid. But the solid body kind of interferes with the hood. So the hood of the vehicle, well, I have to change my view there. The hood of the vehicle is interfering, so we want a nice, good fit. I can also convert the hood into a solid, just like you can see here, and then use a Boolean cut as a solid to be able to chop the hood away from this organic base shape. Then I could go and add my sketch and create my more detailed engineering details, right? My threaded base, and combine it as a solid. So now I have a base that is a solid body with my engineering features, but was created to fit perfectly with my mesh using my Boolean cut. And then I can convert that into a mesh as well. So now I have two mesh bodies up here. And lastly, I can combine those together to make one final 3D printable mesh file. I can export this as an STL, an OBJ, a 3MF file, and send this to a 3D printer very easily. The point simply being that I have the ability to combine all of these different techniques together into one cohesive workflow. There is, however, one more workflow on our agenda today that I think you'll enjoy. So there are cases where instead of the mesh being maybe too detailed, maybe the mesh is actually problematic. Maybe that mesh is irreparable, which does happen from time to time. So let's go and take a look at this. So here I have a mannequin. This would be something you might see at a dressmaker, for example. And maybe I'm trying to model up or 3D print this particular shape or design a new mannequin that's similar in shape. And unfortunately, if I look at this mesh, not only am I seeing these warnings about it not being closed, not having a positive volume, I'll tell you right now that as great as the repair tools are in Fusion 360, if I zoom in here, nothing is going to fix this mesh. This mesh is garbage. This is the worst mesh I've ever seen in my life. But yet, I have been tasked with reverse engineering this in a way that I can make it 3D printable. Well, how can I do that? Well, Fusion 360 gives you workflows that enable that. The subdivisional surface modeling that I showed earlier, you can use here. Here I have my sculpted shape or my form. The green line represents symmetry left to right. And what I can now do is go and edit this shape to give it more detail or to make it match my scan. So I'm going to go and make this match front to back. Let's also do a front view here, and I could shrink this in just a little bit. I can also go and add more detail. So I'm going to go and say I want to insert an edge down here below. And then maybe over here, I'll go and add yet more information. We'll go and add this both directions like this. So if I were to ignore the scan for a second and I look at my body, this looks horrendous. Could I make this better manually? Yes, I absolutely can. But one of the cool things you could do in Fusion 360 is you can actually make it so that the surface body, or the sub D body rather, is going to shrink wrap around scan data. Under modify, you're going to find the pull command. I can select as a target the mesh body that's in the background, and I can select individual vertices of my T-spline body or my form body, and they will magnetically attract, so to speak, or shrink wrap around the scan. I don't like picking things manually like that, especially when there are lots of them. So what I might want to do is to deselect what I've already selected and box select around everything. Now, when I hit OK, I have something that much more closely represents my scan data. It's not perfect at this point, but it's much better. If I want to go and add more detail, that's perfectly fine. I could go and add more subdivisions here, for example. I can take an area like this for, let's say, the bust of the model, and I can go and pull this out just slightly. And then again, use that pull command, and we'll go and select our target once more. Select everything once more, and now that's already looking better. So let's go and take a look at this. This is already a better shape. Does it need some cleanup? Yes, but this is going to help you get to a finished part much, much more quickly. And when you're finished with this design, you hit the finish form button, and it's going to create a surface body for you to go and work with. Now, I'll admit, in this particular case, I got an error. So let's go and take a look at that. I could always go in and take a look at this using our different display modes and be able to fix the problem. And actually, I could see what the problem is. I have some of these polygons like kind of flipped inside out. And so I would just go and clean that up. And what I would end up with is a surface that I could then use to patch, to stitch. And then of course, now I have a solid and I could 3D print it, which is pretty wonderful. That's actually the goal. So let's go and take a look at our plan for today, because we had a plan. So we covered a little bit about me. We covered who is Autodesk and what is Fusion 360. We covered the foundational basics of mesh bodies. And we covered all of the mesh features and workflows that I think are the most pertinent to you and your workflow. If you would like more detail about any of this, remember, let's start that again. If you would like more detail, I have a deep dive into these tools. It's more of a tutorial showing you how to use it. The link is in the chat window, and please join that video and you'll see everything you've seen today, but in a lot more detail on how to actually use it. If you're considering Fusion 360 for your business, Well, you can reach out to our team at Autodesk. We are a global team of salespersons as well as technical specialists like myself, and we specialize in helping you evaluate if Fusion 360 is a good fit for your business. We can compare to whatever your current software is, to whatever your current workflows are. And we can give you a customized presentation similar to what you saw today, but customized to your workflow needs. So if you are considering Fusion 360 for your business, please reach out to us. I'm going to take this and put it into the chat window for you so that you don't have to screenshot it. So just a moment while I place that for everyone. Perfect. And so with that, we have now gotten to the part where you get to ask all the questions you would like. So I'm going to stop my screen share for a moment. I'm going to pull up my Q&A section, and I'm going to answer as many questions as I can. First question by Julio: are these features exclusive to the paid version? The only thing that I've shown you today that is exclusive to the paid version is going to be the conversion from mesh to BREP using the Prismatic option. That is the one that pretty much magically turned that mesh into a fully editable solid body. That is the only feature that is paid only. Everything else that I've shown today is part of all of our licenses, whether it's educational or the free hobbyist license, startup license, and more. So I hope that answers your question. James asked a question about scaling meshes. All right, so James had a problem that I've seen happen a lot, where he would bring in a mesh and it came in the wrong size. There are a couple of reasons for this, and I'm going to give you the full answer. Right? We want to make sure you get the most out of this today. First of all, STL and OBJ files are unitless. So a 1-inch cube shows up as an STL file as a 1 cube, or the 1 by 1 by 1. That's the best way to describe it. It doesn't know if it's 1 by 1 by 1 inches or 1 by 1 by 1 millimeters. So when you bring in a mesh, you have to define what the units are, unless you happen to be using a 3MF file format, which is new to Fusion 360. It's a relatively new file format for mesh files, but it is the most awesome of the bunch for a variety of reasons. But 3MF files come with units, so you don't have to tell it what the size is. But if, for example, you imported an STL file and you chose millimeters, and it actually should be inches, you can use the scale feature in Fusion 360 to scale it. And because the mesh features are now parametric, you can type in that number, multiply by 2.54, and if it turns out that you really meant 25.4, you could just go and change that number and it will update. The other thing to keep in mind, and for this I will share my screen so you can actually see it, is my personal recommendation to all of you is when you want to always go to the mesh workspace or tab and choose insert mesh. I do not recommend going to the data panel here and choosing upload and choosing a mesh file. Can you do it? Yes, but it will very likely come in the wrong units. Insert mesh will always ask you for the units and is therefore likely to be correct from the first place. So I hope that answers that question. Let me see if I could bring in the Q&A in the chat window once more. All right. Riley asked, is it possible to create a surface model from the Prismatic conversion? Great question. So Riley, if what you have is a closed mesh, it will turn it into a solid body. If, however, what you have is a open mesh, it will turn it into a surface body. If you have a closed mesh, but there's some sort of error in the conversion, you might end up with a surface body as well. You can always fix that issue and restitch the surface body into a solid, and that should fix the problem. The stitch tool in the surface menu is a great way to evaluate those issues and also fix them. If you do, however, have a solid body as a result and you want a surface body, just switch to the surface menu and select the face and hit delete. That will delete that face and therefore convert your solid body into a surface. I hope that helps. Someone anonymous asked about correct and accurate dimensions on a mesh like that? I think I might have answered that question earlier about when I imported it, choosing the right units. And if it doesn't come in the right units, you can always use that scale function to get it to the right size. Can combine be used to make reverse images from meshes? The answer is yes. So if you have a mesh body and you want to create, let's say, a mold for a like you have a positive and you want to make a negative mold, you can create a big box, convert that into a mesh using tessellate, and use the mesh combine, where you're removing your positive from the block, therefore leaving the negative. You could also do the same in the solid body features as well. You can convert your mesh positive into a solid body, create a big box, and then use the solid combine tools to turn that box into a reverse mold as well. Perfectly fine. KB would like to know about my 3D printer, the one right behind me. I am the lucky owner of a MakerBot Method X Carbon. It is a phenomenal FDM or FFF 3D printer. It's made by MakerBot, which is really owned by Stratasys, and is a phenomenal machine. For full disclosure, it was provided to me by MakerBot, but I am not required to tell you that it is awesome or not awesome. I am telling you that from my own experience. This thing is a powerhouse. And of all the FFF machines that I've ever used that are inexpensive enough that you could own one for your own house, this is by far the best I've ever used. Any plans, from Tom asked, any plans to port Fusion 360 for Linux? Unfortunately, I am not aware of any plans of doing so. Linux is a great operating system for the people that love to use it, but Fusion 360 is currently compatible for the Mac operating system as well as Windows. We are operating system agnostic in respect to that, but we are not operating currently on Linux. We are testing, and this is public knowledge, so you can do some more research on this, Tom. We are testing for the educational experience running Fusion 360 entirely on the cloud, on Chromebooks. And if that were to be released for the general public, then theoretically you would be able to use Fusion 360 via Linux, just using a web browser in Linux. But currently that is only available to our educational teams and only certain ones. Again, that's being tested. All right, oh my gosh, we have so many questions. I will answer them all though. So Dale is asking, so as long as we have a subscription, do we have access to the mapping feature? If you have a subscription, you have access to everything that I've shown today. Are there advanced rendering capabilities in Fusion 360? Absolutely. Under the design dropdown here, you'll see that we have a render workspace, and we can create beautiful photorealistic ray trace renders from Fusion 360. I'm not going to show you right now how to do that, but I will show you some examples. Give me just a moment while I pull those up. Wasn't exactly ready for that, but I can be pretty quickly. There we are. So all of these renderings you're seeing right now were created in Fusion 360. Some of them are a mix between 3D models in Fusion 360 and canvases or background images. Some of them are entirely Fusion 360, no 2D images whatsoever. We can also incorporate focus. So in an example like this, the focus is on the rear wheel on this airplane, tail dragger in particular, and you could see everything else has become a little bit more blurry. This makes it a little bit more realistic as well. And you could see yet more examples of this. Probably my favorite, however, is this vehicle. This is a Tesla Model 3, excellent vehicle. I actually drove one for my first time over the weekend. That thing's a rocket ship. But this ray trace render was not only created in Fusion 360, but the 3D model for it also entirely in Fusion 360. So you can create some pretty incredible stuff in Fusion 360. Let's get back to the Q&A for a moment and see if I've answered everything. And Troy asked the model, again, that's a MakerBot Method X Carbon. It has, instead of a heated bed, it's a heated chamber, which is fantastic. Not only does it give you kind of more even heating, but it also means that after your part is done printing and you get the support material off, you can actually use the chamber itself to anneal the part and make it stronger. And if you don't happen to live in Denver, where it's super dry all the time, and you have an issue with your materials becoming too humid or moist, you can actually take your material and put it in the chamber, and there's actually a drying process that it will do as well. It's pretty incredible. Lastly, I'll also tell you that I'm using SR30 as my support material, and that is a semi-water soluble support material. I use an ultrasonic bath of a special chemical. It's not a super caustic chemical, but it is not just water, and it melts away or evaporates away or disintegrates that SR30 material. So I actually print pretty much anything I want, even with overhangs, without any problem. Again, that printer is super awesome. I'm going to check the chat window for any last questions here. I don't think any that I can answer, at least right now. So I will just bring it back to the PowerPoint and we'll close out here. We thank you for your time. We understand that learning Fusion 360 or learning about new features is time consuming. We hope, though, that these new features are going to open up workflows and experiences you never thought possible. Today, we covered a whole lot about mesh, how it works, why they're frustrating, and how you can unfrustrate yourself by using these new tools and capabilities in Fusion 360. If you do have any questions about anything that was covered today, we are happy to answer them. It has been my absolute pleasure to meet with you all today. Stay tuned for a follow-up email with a link to this recording, which will also be posted on YouTube. I hope you have a wonderful rest of your day. Thank you so much. And don't forget, with Fusion 360, you can make anything. Have a good one.